Hi everyone. The last lecture we talked about the last topic we talked about the DRV. I give you some example on the DRV and also the difference between the DRV and CRV. So this video we will touch about the CRV. And if you look properly, the DRV I use the yellow bar and the CRV I use the orange bar. And if you look at the slide, this example, we are trying to use the probability density function convert to CDF. Okay, like I mentioned to you just now, PDF, we use integration to get the cumulative density function. So in this case, F equals to 2x. So let's check. When x equals to 1, the fx equals to 2. Right, this line is good. So I would like to change it to cumulative. So first, we need to look at case by case. So even though this one is only cover on, okay, this case is only cover on a bigger or equals to 0. For the case number 1, we still consider x smaller than 0. Oh, it's definitely 0. Because in this case, we only consider x equals or smaller than 1 or bigger or equals to 0. Kan? So number 2 is that x is between 1 or 0. But bear in mind that this is cumulative, and when I do the integration, I use the x to represent the 1 because I'm not using the 1 in this part. Okay. So because I want to integrate along the line, but not until the 1 yet. So remember we have the 2 here, we put it out. Okay, this is a 2. And I do the integration on this part, okay, and I get T2 over 2. And I use them to do the integration. Plug in the x and plug in the 0, and I get my x2. So then, of course, bigger than 1 is 0. It's not in our case. Sorry, of course, bigger than 1, that's the maximum. So the cumulative should always reach until 1 only. So if you have bigger than 1 means something wrong with it, right? So my cumulative density function overall is I use the big capital F equals to, if x smaller than 0, it's 0. If x between 0 and 1, then x power of 2, x bigger than 1 is equals to 1. Okay? Okay. So is that possible that I convert this into PDF? Yes, you can do that by using the integration, differentiation. Just now integration, now differentiation. So how you do that is you do the what's that? How you do that is by referring to the integration. Okay, this is when PDF to CDF, you do the integration. Well, if you want to find back the PDF, you need to use the integration, integrate the formula, and you can get the straight line back. Okay, next we touch about expected value. So expected value, if that is when you do the cumulative, you just add 1x in front and do the integration. Let's say you have two formula variables. So you just times together and do the calculation together. So This is a let's try. Suppose that X is a cutting tool over a given time. It's a probability density function of this. Find the mean. So like I mentioned to you, the mean is X times of this formula. So you add in this, okay, and then you start doing the, sorry, I didn't put it, but you can try first. Add the X, do the integration, and you tell me what is the mean, okay? Okay, next we touched about variance. Variance is X power of 2 times the formula minus the mean. So first, you can find the mean first, and then you use that. Then you use that value times X power of 2. Or you can use X minus mean power of 2 times the equation. Okay. There's another things that you need to aware of is the uniform probability distribution. So in what condition you will use this is when, for example, when the things never change. Okay, for example, every day the school ring, the bell ring. So no matter what day, okay, so the bell ring at the same time, right? So the fx equals to 1 over b minus a. So, and how to get the mean is just simple. You just add the x here, like the formula that we learned just now to get the mean. I wish I had the laser. Okay, so if you look at this properly, okay, this formula, x times the function, and the function is 1 over b minus a. We just add x here. And after the integration, it always get a plus b over 2. If you want to get the variance, so you use the same formula like just now as well. And this is the standard formula for this. Okay, let's have an example. Suppose you have a batch of shaft manufactured with a normal diameter of 10 mm. But due to slightly variation, the function manufacturing process, the diameter varying uniformly between 9.95 to 10.95. We can model the diameter of the shaft as a uniform continuous random variable over the interval. Define the probability function. Since the diameter are uniform, it's not changing, so we can find the probability function very easily. We just plug A and B inside, and then we can get the probability density function is 10. Okay. Probability calculation, let's calculate the probability that randomly select shaft diameter between 9.98 and 10.02. So in order to use this, okay, we do the integration, right? And you can get your value. So in this, indirectly, this means that in this range, there are about 70% of the shaft diameter will at this point, if this is uniform. Okay, so that's all from me. I'll see you next week. Happy Diwali for the Indian and happy holiday for others. Thank you. Bye.